The Trans-Rapid Maglev system, an entirely new train system, the first to overcome the limitations of wheel and rail. Because the vehicle moves entirely without contact, it makes train travel faster, easier on the environment, and more economical. The functions of the wheel and rail on a normal railroad, including support, guidance, propulsion, and braking, are accomplished in the Trans-Rapid through an electromagnetic levitation and propulsion system. Mechanics have been replaced by electronics. Support magnets draw the vehicle towards the guideway from below, while guidance magnets hold it laterally on track. These support and guidance magnets are mounted on both sides of the vehicle along its entire length. An electronic control system ensures that it levitates at a constant height of 10 millimeters above the guideway. While levitating, the vehicle has 15 centimeters of clearance. The Maglev train is propelled and braked by a synchronous long-stator linear motor. This motor is not located in the vehicle itself, but rather in the guideway. It functions on the same principle as a traditional rotating electrical motor, whose stator has been cut open, unrolled, and stretched lengthwise along both sides of the guideway. But instead of a rotating magnetic field, a traveling magnetic field is generated in the windings, one that pulls the vehicle along the guideway without contact. The Trans-Rapid guideway can run at ground level or be elevated, which allows it to be flexibly adapted to individual operating circumstances. The guideway can be elevated where it makes ecological sense. In this case, it won't divide the landscape or developed areas. And the area beneath the guideway can continue to be used as before. The guideway can be built at ground level, for example, to minimize visual impacts or allow easier co-location with existing transportation systems. In any case, the Maglev system's guideway requires less land and space than other transportation systems. The Trans-Rapid vehicle changes tracks by using bendable steel switches. These switches consist of a continuous steel beam elastically bent by an electromechanical setting drive to achieve a smooth turnout. In the bent position, the vehicle can pass over the switch at speeds up to 200 kilometers per hour. In the straight position, the vehicle can run at full operating speed. Trans-Rapid has very favorable alignment parameters with small curve radii and a grade climbing ability of 10%. The Trans-Rapid guideway can therefore be adapted to the landscape instead of the other way around. The operation control system controls and safeguards the vehicles, switches, guideway, and stations along the Maglev route. The vehicle communicates with the control system by means of directional radio data transmission. The vehicle's location is monitored by means of a location reference system integrated into the guideway. The only motor section in operation along the guideway is the one in which the vehicle is currently traveling. When the vehicle passes from one section to the next, the new motor section is automatically switched on. More power is supplied on gradients and acceleration segments along the route than on flat segments. This way, the propulsion power is distributed very economically. It's always available exactly where it's needed. Non-contact technology makes the Trans-Rapid very fast. It is designed for operating speeds of between 300 and 500 kilometers per hour. This enables trip times over medium and long distances, which have until now only been achieved by aircraft. The Transrapid requires less than 2 minutes and a stretch of only 5 kilometers to accelerate from 0 to 300 kilometers per hour. The Maglev system requires significantly less energy than other transportation systems. Used under similar conditions, the specific primary energy requirement of a car is 3 times higher and that of an airplane 5 times higher than the Transrapid. Beyond that, the Transrapid generates no rolling or motor noise. Even at 200 kilometers per hour, it's hardly audible. At this speed, the vehicle glides quietly through cities and population centers. The non-contact technology is also an important economic factor. Due to the low maintenance requirements and energy consumption, the operating costs of the Maglev system are lower than those of high-speed trains. Infrastructure costs are approximately the same. The smallest Transrapid train set consists of 2 sections. Depending on passenger numbers, vehicles with up to 10 sections can be operated. For high-value cargo transport, container sections with a capacity of 15 tons each can also be used. The Transrapid Maglev system offers a high level of comfort and safety. The non-contact levitation and propulsion technology guarantees absolutely smooth running. No jolting can be felt. Passengers don't have to wear safety belts and are free to move about the cars. The innovative technology provided by the Transrapid Maglev system opens up new dimensions in rail travel. Flying on the ground with the Transrapid is easy on the environment, safe, comfortable, and brings passengers directly to the city centers. Whether short or long haul, non-contact technology makes the Transrapid Maglev system the best connection.